Hello everyone, this is Mr. Pell, and we're going to multiply this crazy set of rational expressions, algebraic fractions we sometimes call them. So first thing we're going to do is factor everything. So I'm going to start by factoring this. This is our least favorite kind of factoring when a is something other than 1, but that's going to be a 2x and an x. We're looking to multiply to get that negative 21. So if I do a plus 7 here and a minus 3 there, that's going to give us a positive 14x minus the 3x, which is the 11x middle term that we want. So that's going to work. In the denominator there, I see a GCF, so I'm going to factor out that GCF of x. So there's an x squared plus a 2x plus a 4 left. I'm going to look and see if this can be factored any further, but it can't. The only way to get the 4 is 1 times 4 and 2 times 2, and neither one of those gives you the 2. So that's factored as much as it can be. Over on the fraction on the right, now we're going to do the x cubed minus 8. Hopefully you recognize that as a difference of cubes. So we're going to set up our parentheses. So a is x, b is 2, it's minus plus plus if you're doing your signs first, and then it's the x times the x, the 2 times the x, and then the 2 times the 2. And then on the bottom is just kind of a straightforward trinomial factoring. So we have x, x, to get negative 14, we can do a positive 7 and a negative 2. Whoops, extra per in there. Okay, so now we're going to look for common factors in the numerators and the denominators. And remember, everything's multiplied together, so anything in either fraction, numerator, denominator, can cancel because we can rearrange with the commutative property. So let's see what we've got here. I see an x plus 7 on the top and x plus 7 on the bottom. I see an x minus 2 on the top and x minus 2 on the bottom. And I see an x squared plus 2x plus 4 on the top and also on the bottom. Boy, that's satisfying, isn't it? And now if you look, all we have left on the top is a 2x minus 3. Make that a little prettier. And on the bottom is simply an x. And so that big, ugly mess, this whole thing actually is equal to 2x minus 3 over x. Just a side note here, the whole point is that those two expressions are equal. That big ugly thing and this thing are equal. So if you picked x values and plugged them into this original problem, and then plug that same x value into this, you will get the same answer with some exceptions. Remember that division by 0 in mathematics is seriously problematic. We cannot divide by 0, and it makes things blow up. And so this example is a great example of that. So for example, if I were to plug in, I'm going to choose negative 7. If I plug that into my final answer, I'm going to get an answer. I'm going to get, here, I'll even do it out. 2 times negative 7 minus 3 over negative 7. So I'd get negative 17 over negative 7, which is 17 over 7. However, if I plug that negative 7 into the original problem, I'm going to get an undefined answer. And I can, if I plug that negative 7 into this expression, it's going to give me 0. And so I'm going to have something divided by 0, which blows up and certainly doesn't equal 17 over 7. So basically, these two expressions are equal. Our original problem and our final answer are equal, except for the values of x that make the denominator 0. And so those are our excluded values, we sometimes call them. And so we need to identify what they are. So I'm going to get rid of this. I was just using that as an example just to illustrate the point. So we need to look for the excluded values. And those excluded values, again, are the ones that make any denominator 0. So what we do is we look at the factors of the denominators. So for example, this x plus 7 right here, that gave me the value of x that would make that 0 is negative 7. So x cannot be negative 7. Then if I look at this term here, at x minus 2 factor, x cannot be 2. If I look over here, that x value can't be 0, because if I plug in 0, that denominator will blow up. I'll get 0 in the bottom, which is no good. Now this factor is not factorable. It turns out it only has imaginary zeros. When I ask you for the excluded values here, I'm not going to make you include, first of all, we wouldn't include imaginary numbers, so you really don't have to worry about that. I'm never going to make you do one like that where it's crazy. And so it'll simply be linear factors like the ones that we saw. And so your excluded values, the way you would write that on paper is to just list the values that x cannot be, which would be negative 7, 0, and 2. And so in formative, you're just going to list those 3 numbers in order from least to greatest when I ask for it. Sometimes I'll just say, assume all values of x are defined, which basically means let's not really worry about those special case excluded values. But if I ask for them, that's how you find them. All right, that's all for now. Thanks.